So we're going to start out with the nitrate reduction, and like I said, this is anaerobic respiration. So what that means is that these bacteria are going to be able to use something else other than oxygen as a terminal electron acceptor. So these bacteria have an electron transport chain. They're able to do respiration, but they're going to be using something else other than oxygen as a terminal electron acceptor. So if we're talking about nitrate reduction, these bacteria are going to be able to use nitrate as the terminal electron acceptor. And these organisms are also known as facultative anaerobes because they're able to do the anaerobic respiration. They're able to use something else other than oxygen. So they're not just strictly aerobes, they're facultative anaerobes. So we're using nitrate as a terminal electron acceptor. So here's our nitrate, NO3. That's the chemical formula for it, so NO3. So anytime you see that, that's nitrate. Anytime you see TE8, that's short for terminal electron acceptor. So what are we talking about? We're talking about once the bacteria does glycolysis in the Krebs cycle, it gets its reducing power. It's sucked those electrons off of sugar or whatever it's using, and the electrons are shuttled through the electron transport chain. Well, at the end of the electron transport chain, these electrons don't have any more energy. Their energy has already been used, so you could call them used electrons. There's no more energy left. So the cell has to do something with them. They can't just be chilling. Okay? Electrons always have to have somewhere to go. So the bacteria, if we're doing aerobic respiration, uses oxygen as the terminal electron acceptor, and that's what we mean by TEA. At the end of the electron transport chain, the bacteria is going to take the spent electrons, place it onto oxygen, and form water. Okay, that's the ultimate end product of respiration. And now, of course, you're making ATP because of chemiosmosis, but the electrons have already done their job as far as that goes. So they're used up, place them on oxygen, reduces oxygen to water, and that's your end product. That's aerobic respiration. So anaerobic respiration, our NO3, our nitrate, is serving in place of the oxygen. So the nitrate is sitting at the end of the electron transport chain. The used up electrons are placed onto nitrate, reducing it, because that's what reduction is. We're adding electrons, add electrons to the nitrate, and reducing it to nitrite. So here is the first part of that reaction. This right here is nitrate reduction. Okay, just that small part is nitrate reduction. So we have our terminal electron acceptor nitrate. Those electrons are added. It's reduced to nitrite. Okay? The enzyme that's responsible for doing this is nitrate reductase. It's reducing nitrate. So nitrate reductase is the enzyme that's responsible for taking the electrons, placing them onto nitrate, and producing nitrite. You produce nitrite in water. Now, some bacteria can only do this. Some bacteria only have the enzyme nitrate reductase, so they're only going to be able to reduce nitrate to nitrite. However, there are some bacteria that can take it a step further and do what is called denitrification. This is where the bacteria take the nitrite ions that they produced, use it as a terminal electron acceptor, add electrons to the nitrite, further reducing it down to nitrous oxide and nitrogen gas. And ultimately the nitrogen gas, if it does fixation. Okay? So, like I said, some bacteria can only do nitrate reduction. Some can bring it all the way down to denitrification and fixation. Some bacteria do not produce nitrate reductase. If they don't produce nitrate reductase, they're not going to be able to do any of this. If they don't have nitrate reductase, okay, this is a stepwise process. This step has to happen before this step. So if they don't produce nitrate reductase in the presence of nitrate, they're not going to be able to use the nitrate at all, and those would be negative for nitrate reduction. Okay, so we would have 3 tubes. Okay, this is what the tubes look like. Now these have been inoculated, so but this is called nitrate. Okay, so this is nitrate media. Basically, it's media that has nitrate in it, and we're going to see what your bacteria does with the nitrate. Does it have the ability to reduce the nitrate, do denitrification, or can it do neither one of those and it's not going to use the nitrate at all? So those are our three options. Now, you'll notice that there is something else in the tube. That's that Durham tube. And if you remember from the carbohydrate test, the Durham tube is there to catch gas. Remember what I said for denitrification. You could potentially get that nitrogen gas that's produced. So we want to see if there's any gas that's being produced in the tube. To do that, you add the Durham tube to be able to catch the gas. So all I did to inoculate these was use my loop, okay, flame it, go in and get my bacteria, dip and swirl. That's all you do. Now I used two bacteria. This last one I haven't inoculated yet, but I wanted to show you what a negative test looks like, so that's why I'm using this one. But the two bacteria that I used were E. coli and Pseudomonas. Now normally, if you were doing your unknown with this, you would have your unknown, your E. coli, and your Pseudomonas. Okay, but I inoculated E. coli and Pseudomonas, and then I'm going to have a negative control to show you what a straight up negative test looks like. Okay, so the first thing that we need to add to the tubes to read the results are the first reagents. The first reagents for the nitrate test are nitrate solution A and nitrate solution B. So here's my nitrate solution A and my nitrate solution B. So I'm going to add 10 drops of A and 10 drops of B. Okay, so I'm going to go ahead and do that now. Now this is reacting with nitrite. So if there is any nitrite in the tube, these two solutions are going to react and give you a red color. If there's any nitrite. So let me repeat myself on that. These two reagents, A and B, react with nitrite. So here's my 3 tubes, E. coli, Pseudomonas, and there's my negative control. Here's my E. coli tube. Look how red that is. So that is a positive reaction for nitrate reduction. That means that E. coli reduced the nitrate to nitrite, and that's all that it did. It did not go any further. So E. coli is a nitrate reducer. So if you got this reaction with your unknown, you would be done. You would circle positive for nitrate reduction, and then you would be done, because that means that your bacteria didn't go any further with the reaction. Now we have our Pseudomonas that's left. You can see that I got no color change. Okay, nothing happened. It's kind of like a yellowy looking color. Nothing happened. And then for my negative control, of course, again, nothing happened. It's like a yellowy looking color. So, now I have to ask myself, what did the Pseudomonas do? Did it take it a step further and do denitrification and fixation? Or did it not use the nitrate at all and is just straight up negative for the nitrate test? So, to test for that, I'm going to add zinc powder. This is the second half of it. Now, let me tell you what the zinc does. The zinc, if any nitrate is still in the tube, this zinc is going to reduce it to nitrite. Now, we've already added A and B to the tube. That's already still in there. So, once I add the zinc, if there's nitrate in the tube, it will reduce it to nitrite, and the tube will turn red. If you get that reaction, that is a negative result. So after you add the zinc, if you get red, that is a negative result. That means that the nitrate was still in the tube. So the bacteria didn't use it at all. Now, once I add my zinc, if I still get no color change, then that means that the bacteria did denitrification and fixation. There is no more nitrate, there is no more nitrite, okay, and it produced the nitrous oxide and then ultimately the nitrogen gas. So that's what we're going to do now. So I'm just going to shake a little bit into the tube cap because I don't want to put too much in my tube. Okay. So I'm going to give it a little swirl. So as you can see, I again got no color change. Now it is looking a little gray. It's just because of that zinc powder. As it sits and settles, you would be able to see more of the color of the media instead of all that zinc powder. But you can also see how many bubbles are there. You see that Durham tube on the inside? There's bubbles on the inside of that. That's another indication of denitrification. Okay? So the Pseudomonas did nitrate reduction and denitrification. So it's positive for both. Now, you'll also see as this settles, this is starting to turn red. The longer it sits, the redder it's going to turn. Okay? Might be a little hard to see. Like I said, the longer it sits, it eventually will get this red. So you can kind of see that, compare it, it's getting a little redder. So this is a straight up negative. This means the nitrate is still in the tube. The bacteria didn't do anything with it at all. So as you can see, as it settles, it's settling out a little bit so that you can see that Durham tube a little bit better. So as a review, we are asking ourselves, does our bacteria do nitrate reduction, denitrification, or nothing at all? E. coli was positive for nitrate reduction. That means that once I added the A and B, it turned red, reduced the nitrate to nitrite. That's my positive results. Pseudomonas did nitrate reduction and denitrification. So once I added my A and B, there was no nitrite to react with the A and B. So there was no color change. I added the zinc. Again, still no color change. And I've also got lots of gas in the tube. So this is positive for both nitrate reduction and denitrification. And then I've got my all-out negative. And as you can see at the top there, that one's starting to turn red even more. That means that there was still nitrate in the tube. So no nitrite. So once I added A and B, I got no color change. And once I added the zinc, that tells me that there was still nitrate in the tube. So that is my negative result for nitrate reduction.